Hello all. Today we are going to study and understand the route table formation RIP and OSPF protocols in NetSim. NetSim is a network simulation tool that allows you to create a network, virtually simulate it, and also to analyze the results. Let's start. Firstly, we will learn about some basics about RIP protocol, and then we will move on to the practical execution of experiments using NetSim. Similarly, for OSPF protocols we will learn some basics and then we will move on to the practical execution of experiments using NetSim. Overview of RIP protocol. RIP stands for Routing Information Protocol. It is a dynamic, distance vector routing protocol. RIP is designed to help routers exchange routing information within a local network and make decisions about the best path to reach a destination. RIP uses hop count as the metric to determine the best path to a destination network. It uses the Bellman-Ford algorithm to calculate the best path to a destination based on the minimum hop count. RIP advantages are: 1. Simplicity. RIP is easy to configure and manage, making it suitable for small to medium-sized networks. 2. Hop-based. RIP uses a simple metric called hop count, representing the number of routers a packet must traverse to reach its destination. Each hop adds 1 to the count. 3. Periodic updates. RIP routers exchange routing information regularly at fixed intervals, default, 30 seconds, ensuring that the network topology is up to date. RIP limitations are: 1. Convergence time. RIP can have longer convergence times in large networks, as it relies on periodic updates and might take time to adapt to changes in the network. 2. Limited scalability. In larger networks, the hop count limit of 15 can become a limitation, and the frequent updates can consume bandwidth. Let's understand about route formation of RIP protocol. 3 processes involved in route formation of RIP protocols is: 1. Update process. Routers exchange routing information using RIP updates. Updates contain information about reachable networks. 2. Metrics. RIP uses hop count as a metric, number of routers between source and destination. Lower hop count means better path. 3. Route table entry. Each router maintains a route table. Route table entry format: destination, next hop, hop count. Let's perform the RIP experiment practical using NetSim. Open NetSim and click on Experiments. Expand the Internetworks section and then expand the Routing and Switching section and then click on Route Table Formation in RIP and OSPF experiment and click on RIP experiment sample. Step 1. A network scenario is designed in the NetSim GUI comprising 2 wired nodes, 2 L2 switches, and 7 routers. Step 2. Go to Router 1 Properties. In the application layer, the routing protocol is set as RIP along with its associated parameters. The routing protocol parameter is global. That means changing router 1 will affect all the other routers. So, in all the routers, the routing protocol is now set as RIP. Step 3. Right-click on App 1 Custom and select Properties or click on the application icon present in the top ribbon or toolbar. The transport protocol is set to UDP. A custom application is generated from wired node 10, which is the source node, to wired node 11, which is the destination node, with a packet size of 1460 bytes and inter-arrival time of 20,000 s. Step 4. You can enable the packet trace from the Configure Reports tab. Using packet trace we can track the route that the packets have chosen to reach the destination based on the routing information protocol RIP that is set. Step 5. Run the simulation for 100 seconds. Let's wait for the simulation to complete. After the simulation is completed, you can see that the NetSim result dashboard will be loaded. Let us analyze the output of the RIP protocol simulation. Open the packet trace using the Open Packet Trace option in the result dashboard. Wait for the packet trace to open completely. Make sure that Microsoft Excel is installed before opening the packet trace. Filter the first column, packet ID, to 1, and observe the shortest path chosen by the RIP protocol from wired node 10 to wired node 11 is wired node 10 to L2 switch 8, L2 switch 8 to router 1, router 1 to router 7, router 7 to router 6, router 6 to L2 switch 9, L2 switch 9 to wired node 11. RIP chooses the lower path, the number of hops is less, to forward packets from source to destination since it is based on hop count. As you can see in the NetSim scenario, the number of hops is less in the lower path. So the RIP has chosen the shortest path and best path as the lower path via router 7. You can also see the hop count as metrics in the result dashboard. In the result dashboard in the left panel, expand the IP forwarding table option to the route table formed by RIP protocol in each router. Click on Router 1 option, and Router 1 routing table will be opened. Click on the detailed view option to the protocol and metrics chosen by RIP protocol.